Alright, so everyone should have this paper out on their desk. It says approximating square roots in simplest radical form. Part 1, approximating square roots. What if the number isn't a perfect square? How do I find the square root? So our whole warm-up was about perfect squares, two numbers that you multiply to, two of the same numbers that you multiply together to get a bigger number. The square root, if it's not a perfect square, is going to be an irrational number. Can someone give me an example of another irrational number that you know? Has to do with circles. What is it? Pi. Pi is irrational because it's a decimal that goes on and on forever without a pattern. It doesn't repeat. It doesn't ever end. So irrational numbers are non-terminating, non-repeating decimals. Pi and non-perfect squares are always irrational. So, since we can't give an exact answer, we're just going to estimate it by finding the two consecutive numbers the square root will lie between. Does anyone know what consecutive means? Or could you give me an example? Okay, consecutive means one after the other. An example of consecutive numbers would be like 3 and 4, 10 and 11. So they're numbers that you like use to count with that come back to back. Alright, the easiest way to do these problems is just to use your calculator. I will explain the more mathematical way, but you'll always have a calculator, so you may as well know this. If I want to know between which two consecutive numbers the square root of 57 lies, I'm going to do 57 in my calculator, hit the square root button, which is right next to the division sign, and you get 7.549. What two numbers is 7.54 between? 7 and 8. That's our answer. The other way of doing this is knowing all of our perfect squares. So, I know like 6 squared is 36, 7 squared is 49, 8 squared is 64, 9 squared is 81. So I know these perfect squares are kind of near the square root of 57. So the square root of 57 is going to be between the square root of 49 and the square root of 64. Those are the two nearest perfect squares. The square root of 49 is 7. The square root of 64 is 8. So the square root of 57 is between 7 and 8. But again, you always have a calculator. This is just like it's really good to know your multiplication facts and your integer rules. It helps you just become more fluent and do math faster. Knowing all of your perfect squares will help you do this faster. So you guys do this one. It has a negative number out in front. And what two numbers does the negative square root of 18 fall between? Negative 4 and negative 5. So it's between the negative square root of 25 and the negative square root of 16. Or if you were just do it on your calculator, 18, take the square root, and then down next to the equal sign, we'll make that number negative, so it's negative 4.2. Negative 4.2 is between negative 5 and negative 4. Okay, example 2 says, which pair of numbers are both between 5 and 6? Again, you could use your calculator and find 8 different square roots. This one I do think it's a lot easier if you know your perfect squares. So, what's 5 squared? 25. So we want numbers between the square root of 25, which is 5, and what's 6 squared? And the square root of 36. So I'm looking for numbers between 5 and 6. Rewriting them using perfect squares is the square root of 25 and the square root of 36. So, is 22 between these numbers? No, that's too low. Is 25 between these two numbers? 25 is not between these numbers because it is exactly 5, and we want between. Between means not including. Is 28 between these two numbers? Yes. Is 38? No, 38's too big. And is 27 between these numbers? Is 35? Okay, so D is our answer. If we wanted to verify that we did that correctly, definitely use your calculator. 5.196 is between 5 and 6, and the square root of 35, 5.916 is between 5 and 6. Okay. Example 3, which could be point A. What perfect squares is A between 9 and 16? So we want to pick a number that's between the square root of 9 and the square root of 16. Look at these 4 answer choices. Don't shout it out. Just think which number you would choose. And now you can shout it out. Which number would you choose? D. The square root of 13 is between the square root of 9 and the square root of 16. We could, again, use our calculator. 13, take the square root. 3.6 is right between 3 and 4. So if you're having a hard time converting into perfect squares, use your calculator. Okay, in example 4, we have to make a correction. This should say the negative square root of some number lies between negative 14 and negative 15. So I want a number that when I take the square root and make it negative, I get numbers between negative 14 and negative 15. In order to do that, we're just going to go backwards. What's the square root of, or what's 14 squared? What is it? 196. So this is 14 squared. And what's 15 squared? Okay. So, all I need to do is pick a number that's between 196 and 225. Someone give me a number. 200. 197. 223. Any of those numbers work. Notice I just wrote that number. I did not write it like this because this negative square root is already included in that question. It says the negative square root of. We don't want to take a double square root, so we just write the number down. You will have a question like that on your test. It is number 15 on your homework. 15 says has a positive square root, so you don't write that square root sign. You will also have one like this on your test or your quiz. Don't write the square root sign in that blank or I will mark it wrong, because then you're taking double square roots. There's also one like this on your task cards today. Okay, what questions do you guys have? It's a lot of information, but you can use your calculator. No? Okay, flip it over. This is where it gets hard. Part 2 is simplest radical form. It is among the more difficult things that we will do this year. Not the hardest, but it takes a while to get the hang of sometimes. So, instead of telling me what 2 consecutive integers a square root falls between, this time you will give the answer in simplest radical form. Things you need to know. A factor. The factors of a number are those numbers that divide exactly into the number. So, someone tell me 2 factors of 10. 5 and 2. 5 times 2 is 10. Factors of 10 are 5 and 2. What are factors of 12? 6 and 2 or 3 and 4. Okay? Prime is a whole number with exactly 2 factors, one in itself. So 3 is a prime number. 5 is a prime number. 7 is a prime number. 11 is a prime number. 13 is a prime number. 2 is a prime number. These are prime numbers that you have to know. When we're doing our simplest radical form, once we get to that point, we'll stop. To make a factor tree, to do your prime factorization, you're going to split the number you're factoring into 2 factors. You can choose any 2 factors. As long as they are factors of those numbers, they multiply together to get that bigger number, it will end up working out. You'll continue to split each factor until there are only prime factors left. Circle the prime numbers, and then we're going to write prime factorization using multiplication. So if you have already finished writing those words in the blanks, you can look at the number. In example 1, 32, think of 2 numbers that multiply together to get 32. And write them down. Amber, what 2 numbers make up 32? 8 times 4 is 32. If I were doing this on my own, I would immediately see that 2 is an even number and just do 2 as my first factor. So 32 divided by 2 is 16, so I would have chosen 2 and 16. But 8 and 4 is also going to work out. What 2 numbers make up 8? 4 times. Okay. Remember, we're always multiplying. I'm not writing a 4 here because 4 times 2 is 8, not 4 plus 4. 2 is a prime number. It was one of the numbers I wrote up here on my list. What 2 numbers make up 4? 2 times 2 is 4. And then this one, we haven't finished factoring. What 2 numbers make up 4? 2 times 2. So, to get 32, the number in the square root, 2 times 2 is 4, times 2 again is 8, times 2 again is 16, times that last 2 is 32. So these 5 numbers are the 5 prime numbers that make up 32. So prime factorization is breaking down a number until you have only prime numbers. Okay, so the square root of 32 is equal to the square root of 2 times 2 times 2 times 2 times 2. So I took all of those numbers that I circled and I wrote them down inside the square root. A lot of people have a hard time making the factor tree because they don't know all of their factors of numbers. They don't know what prime numbers are. Or the biggest mistake people make is they try to add instead of multiply. So you're always finding numbers that multiply together, not that add together. Okay, our next step is to make some buddies. So here's a pair of 2's. Those 2's are exactly the same. They form a buddy. What is 2 times 2? And what's the square root of 4? 2. So 2 times 2 is 4. When I take the square root, I get 2 again. Anytime you make a buddy, you're going to put it outside the square root sign. Here's another pair of 2's. These 2's are exactly the same. What is 2 times 2? 4. When we take the square root of 4, what do we get? 2. So we're going to take another pair and write it outside the square root sign. This 2 does not have a buddy. There's no one to match with. There's no one left. I would have to have another 2 in there in order to pull it outside. So I'm going to leave this 2 on the inside of the square root. On the outside, I was able to group 2 sets of 2 together, so 2 times 2 is 4. And on the inside, I just have the square root of 2. Alright, for this next example, I'm going to have you guys do the factor tree on your own. So factor 96 into only prime factors. When I look at that, I see that a 9 and a 6 will both go into 3. So I do 96 divided by 3 and do 3 times that number as my first factor. You could work and try and find other ones, but 3 is definitely going to work. If you're ever unsure of what your first factor is going to be, just start dividing it by prime numbers, and one of those numbers would work. So I would start with 2, and then 3, and then 5, and then 7, and it will eventually work. If you've had a hard time getting started, I put the first 2 factors up there. That's okay. We're going to end up with this one. Yeah, we'll do the same. If you started with something other than 3 and 32, like 6 and 16 or something, that's okay. It's going to end up to be the same prime factors in the end. Alright, so it doesn't matter how you start, but after you do your prime factorization, you should have 1 3 and 5 2's. Rewrite those so that it's 3 times 2 times 2 times 2 times 2 times 2 underneath the square root sign. So, if we were to check ourselves, 3 times 2 is 6, times 2 is 12, times 2 is 24, times 2 is 48, times 2 again is 96. So, either do that in your head or use your calculator. When you multiply these numbers together, you'll get 96. And as long as you get 96, you know you have the right prime factorization. If you check your work and you don't get 96, that probably means that you found two numbers that add together instead of multiply together. Okay, so again, we're going to find some buddies. So 3 does not have a buddy anywhere. So I'm going to leave that underneath the square root sign because I had no one to buddy it up with. There were no other 3's there. I see a pair of 2's right here. I'll buddy them up. 2 times 2 is 4. The square root of 4 is 2. So anytime you see a buddy, you write it down one time on the outside. There's another pair of 2's here. So I'm going to write that one down one time on the outside. And then this time, we're left with another 2 on the inside. All the numbers on the outside will multiply together. 2 times 2 is 4. Write the square root sign. All the numbers on the inside we multiply together. 3 times 2 is 6. So 96 in simplest radical form is 4 times the square root of 6. Alright, you guys down below, write a summary in complete sentences. What are the most important things to remember when expressing a square root in simplest radical form? If I were you, I would make sure that I include the part about multiplying the numbers together at the end and the part about buddying things up and pulling out one of the buddies on the outside in the end.